Hi everyone, and welcome to this video going over our Chapter 6 study guide on trigonometry. Let's get started. In Part A, it says determine whether the following side lengths can form a triangle. So step 1, I have to see if a triangle can even be formed. If a triangle can be formed, I am going to determine if the triangle is acute, right, or obtuse. So in order for a triangle to be formed, any two side lengths added together have to be bigger than the third side. So for example, 3 plus 4 needs to be bigger than 6. 4 plus 6 needs to be bigger than 3. And 3 plus 6 needs to be bigger than 4. Notice how I check all combinations of any two of the side lengths added together and checking against that third side. 3 plus 4 is 7, and 7 is bigger than 6, so that's a check. 4 plus 6 is 10, which is bigger than 3, that's a check. And 3 plus 6 is 9, which is bigger than 4, that's a check. So yes, a triangle can be made. In order to determine what kind of triangle can be made, we are going to plug this into the Pythagorean theorem. So 3 squared plus 4 squared, and I'm going to see how it compares to 6 squared. Make sure the biggest side goes last. 3 squared is 9, 4 squared is 16, and 6 squared is 36. 9 plus 16 is 25. 25 is smaller than 36. So since c squared was bigger, this triangle is obtuse. So make sure that you check that a triangle can be formed first before plugging it into the Pythagorean theorem. Let's try number 2. First, I have to check that 5 plus 7 is bigger than 15. I have to check that 7 plus 15 is bigger than 5. And I have to check that 5 plus 15 is bigger than 7. 5 plus 7 is 12, which is not bigger than 15. I don't even need to check the other combinations. I know for a fact that this is not a triangle. And since it's not a triangle, I don't need to classify it since a triangle can't even be made. Now we're going to move on to talking about our special right triangles. Let me remind you of our patterns. In a 45-45-90 triangle, this is an isosceles right triangle, which means the side lengths are going to be the same. So we have x and x for the legs. And in order to get the hypotenuse, we are going to multiply that leg by radical 2. For a 30-60-90 triangle, since all of the angles are different, all of the sides are different. Across from 30, we call the x side. Across from 60, we take x and we multiply by radical 3. And across from 90, the hypotenuse, we are going to double x. So step 1 is to write out the rules on your triangle. So notice in number 4, I have a 30-60-90 triangle. And so I'm going to write in my rules. Across from 30 is the x side. Across from 60 is the x radical 3 side. And across from 90 is the 2x side. Find the length that they give you and set it equal to the rule that you wrote on that side. So I'm going to say x radical 3 equals 9 radical 3. And we're solving for x. So if x is being multiplied to radical 3, to get x by itself, I need to divide by radical 3, which crosses this off, leaving me with just x. And those will cross off as well, leaving me that x is 9. So now everywhere where I see x, I'm going to plug in 9, which tells me that y is 9. And to get the double x side, I have to do 2 times 9, which is 18. So notice how it asks for x and y. They're referring to their labels. So this tells me that on the x side, I got 18. And on the y side, I got 9. Let's try a 45-45-90 triangle. So on a 45-45-90 triangle, I have x, x, and x radical 2. I'm looking for the side that they gave me, and I'm setting it equal to its rule. So 4 is equal to x times radical 2. To get x by itself, I need to divide by radical 2 to both sides. And so I get that x is equal to 4 over radical 2. But remember, it's illegal to leave a radical in the denominator. So to get rid of it, I need to multiply the top and the bottom by radical 2. So 4 radical 2 over radical 4, but radical 4 can be simplified to just 2. And then I can cross off 4 divided by 2 will just give me 2 radical 2. And so this is x. So everywhere where I see x, I can go ahead and put in 2 radical 2. So 2 radical 2 and 2 radical 2. So this tells me that both a and b are 2 radical 2. Since this is an isosceles triangle, the legs will match. In part C, it says find the missing side length indicated using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And it says leave your answers in simplest radical form. So we're not rounding, we are going to simplify our radical at the very end. Make sure that your hypotenuse goes last. So in number 8, I'm going to locate my hypotenuse. So my x is going last. So I have 30 squared plus 15 squared equals x squared. 30 squared is 900, and 15 squared is 225. Adding those together, I get 1,125 equal to x squared. But I don't want x squared, I want just x. So to get rid of a square, I need to square root both sides. And I'm going to simplify if I can. Remember, our perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. I would start in order and divide the value in the radical by each of your perfect squares until you find one that works. So I'm going to do 1,125 divided by 4, and I get a decimal. So I'm moving on to 9. 1,125 divided by 9, and I get 125. The square root of 9 is 3, so now 3 is on the outside, and I'm going to see if I can divide 125 by any of my perfect squares. So 125 divided by 4, I get a decimal. 125 divided by 9, I get a decimal. 125 divided by 16, I get a decimal. 125 divided by 25, I get 5. So I can break this up as the square root of 25 times the square root of 5. The square root of 25 is 5. And 5 can no longer be simplified. So 5 is going to stay in the radical, and any numbers I brought to the outside, I'm going to multiply. So 3 times 5 will get me 15. Let's try number 9. I'm going to start by locating my hypotenuse because that's going to tell me which number goes last. And so 33 is going last. So I have x squared plus 29 squared equal to 33 squared. 29 squared is 841. 33 squared is 1,089. And I'm trying to get x squared by itself. So I'm going to subtract 841 to both sides. And I get 248. And in order to get rid of the square, I'm going to square root both sides. And I'm going to go through my perfect squares until I find one that divides 248. So 248 divided by 4, I get 62. The square root of 4 is just 2. And now I'm going to see if 62 can be divided by any perfect squares. So 62 divided by 4, I get a decimal. 62 divided by 9, I get a decimal. 62 divided by 16, I get a decimal. 62 divided by 25, I get a decimal. 62 divided by 36, decimal. 62 divided by 49, decimal. And then 64 is bigger than 62, which means there's no perfect square that divides 62. So 62 is going to stay in the radical, and 2 is going to be on the outside. So make sure if your instructions say leave in simplest radical form, that you simplify your radical. If the instructions say that you're allowed to round, you can go ahead and plug in your radical in your calculator. Let's move on to our next section. Use SOHCAHTOA or inverse SOHCAHTOA to find the missing sides or angles indicated. Round missing sides to 2 decimal places and missing angles to the nearest degree. So I'm going to start by labeling my sides. If this is my angle, across from my angle is my opposite. Next to my angle is my adjacent, and across from the right angle is the hypotenuse. So notice how I have labels on the hypotenuse and the adjacent. So that's A and H. A and H is going to be cosine. So cosine of 62 is equal to A over H, just like SOHCAHTOA says. So I have 13 over X. Once I have my ratio set up, I add a 1 under the cosine, and I cross multiply. 1 times 13 is 13, and I have X times the cosine of 62, but I need X by itself, so to get X by itself, I'm going to divide by the cosine of 62. And I will plug this into my calculator, 13 divided by the cosine of 62, and since this is a side, I'm rounding to 2 decimals. So I got 27.690, rounding at the second decimal place. 0 is not big enough to make the 9 go up, so my answer stays 27.69. Let's look at 13. So in 13, this is my angle. My angle is missing, so I'm looking for the angle. I still label my sides. My 22 is opposite the angle. The 25 is the hypotenuse, and the blank side's my adjacent. Looks like I have labels on the opposite and the hypotenuse side. So that's going to be O and H, which is sine. So sine of the question mark is equal to O over H, so 22 over 25. Since I'm trying to find the question mark, I need to get rid of sine, and I get rid of sine with the inverse sign. So I'm going to inverse sine both sides. And so in my calculator, I am plugging in second sine of 22 divided by 25. And I get 61.6. Since this is an angle that I'm solving for, I'm rounding to the nearest degree, so the nearest whole number, so the number right before the decimal. I look at its neighbor, and the 6 is big enough to make the 1 go up, so this is going to be 62 degrees since it's an angle. So notice if I use inverse, that means I'm solving for an angle. I'm going to round to the nearest whole number. And if my x is one of the sides in the fraction, I'm not going to use inverse. I'm just going to cross multiply, and I round to 2 decimals. Moving on, it says use the law of sines or the law of cosines to find the missing sides or angles indicated. Round missing sides to 2 decimal places and missing angles to the nearest degree. The law of sines is the sine of angle A over the opposite side, little a, is equal to the sine of angle B over the opposite side, little b. The law of cosines is c squared is equal to a squared plus b squared minus 2ab cosine of c. In 18, it says find the measure of angle B. So I'm going to put an X on angle B. I always look to use the law of sines first. I find that one the easiest. But we can only use law of sines if I have a complete pair. So I'm going to fill in my little letters. Across from A is little a, across from B is little b, and across from C is little c. I am looking for a letter to have both its big letter and its little letter filled in, meaning I have both an angle and an opposite side pair. And if you look, I have capital C and lowercase c. That's my complete pair. So I'm going to say the sine of 78 over 38. And since I'm trying to find angle B, I need to use the side across from B is equal to the sine of B over 27. Once I have my proportion set up, I cross multiply. So 27 times the sine of 78 is equal to 38 times the sine of angle B. I need to get angle B by itself, so I'm going to divide by 38 to both sides. is still not by itself. It's being blocked by the sine. So to get rid of sine, I need to inverse sine both sides. So the measure of angle B is going to be equal to all of this plugged into my calculator. So second sine to get the inverse of 27 times, make sure you press the sine button, of 78, close that parenthesis, and divided by 38. Since this is an angle, I'm going to be rounding to the nearest whole number. I get 44.0. I'm rounding right before the decimal. 0 is not big enough to make it go up, so the measure of angle B is 44 degrees. Let's try number 20. So in 20, it does not look like I have a complete pair where I have an angle and its opposite side. And that's because I know none of the angles. But I do know all of the sides, and if I'm trying to find angle B, I'm going to use the law of cosines. So I'm going to use the law of cosines that starts with little b. So first let's put in our little letters. Across from big B is little b, across from A is little a, and across from big C is little c. Since I'm trying to find angle B, I'm going to use the version that starts with little b. So little b squared equals a squared plus c squared minus 2ac cosine of angle B. I'm now going to plug in what I know. Little b is 13, so 13 squared equals little a is 21, so 21 squared, plus little c is 29, so 29 squared, minus 2 times little a, which is 21, times c, which is 29, times the cosine of angle B, which I'm trying to find. Since I'm trying to find angle B, I need to get all of this other information to the other side so that I can get B by itself. I'm going to start by simplifying. So 13 squared is 169. 21 squared is 441. 29 squared is 841. Then I'm going to multiply 2 times 21 times 29, and this gets me 1,218. The 441 and the 841 I can combine, so 441 plus 841 gives me 1,282. And remember, this is a really big mistake that I see people make. The 1,218 has a cosine attached to it, which means it's not a like term with the 1282. I cannot subtract those because the 1282 does not have a cosine. What I do want to do is I want to subtract 1282 to the other side. And this gets me negative 1,113 equal to negative 1218 cosine of B. Because this 1218 is being multiplied to the cosine, I need to divide to get rid of it. So I have negative 1,113 divided by negative 1218 equal to the cosine of angle B. Notice how B is still not by itself. In order to get rid of that cosine, I have to inverse cosine both sides. So in my calculator, I'm typing in inverse cosine of negative 1,113 divided by negative 1218. And I get 23.96. Since this is an angle, I'm rounding to the nearest whole number. The 9 makes the 3 go up, so this is 24 degrees. So make sure that if you're using the law of cosines and you're trying to find that angle, that you simplify each step and get everything to the other side so that you get B by itself. In F, it says look at the triangle and determine the method needed to solve for the missing angle or side. So I'm just giving you a triangle and you have to figure out if we're using Pythagorean theorem, special right triangles, SOHCAHTOA, inverse SOHCAHTOA, or the law of sines or cosines. So for example, in 22, I have a non-right triangle, which means my only options are the law of sines or the law of cosines. I'm first going to look to see if I have a complete pair, and I do. 42 degrees and 27 are across from one another, so I'm going to use the law of sines. Sine of 42 over 27 is equal to the sine of theta over 22. I'm going to cross multiply. I have 22 times the sine of 42 equal to 27 times the sine of theta. In order to get theta by itself, I need to divide by 27. And in order to get theta by itself, I need to get rid of sine by using the inverse sine. So I'm inverse sining both sides. So inverse sine of 22 times the sine of 42, make sure you close that parenthesis, and divide by 27. Since theta is an angle, I'm rounding to the nearest whole number, so I get 33.0. The 0 is not big enough to make the 3 go up, so this is just 33 degrees. In 23, I know 2 out of the 3 sides of my right triangle. Since this is a right triangle, I can go ahead and use the Pythagorean theorem. I locate my hypotenuse, so I know what number is going to go last. So because 13 is on the hypotenuse, 13 is going to go last. I have x squared plus 11 squared equals 13 squared. 11 squared is 121. 13 squared is 169. I need to get x all by itself, so I'm going to subtract 121 to both sides. And I get x squared is equal to 48. And then I need to square root both sides to get rid of the square. Now, the last time we did the Pythagorean theorem, earlier in this video, it said that we needed our answers in simplified radical form, and so that's why we had to simplify our radical. But if you notice in this section, the instructions say I'm allowed to round. So I'm just going to plug in the square root of 48 in my calculator. So I'm going to hit the second button and the x squared button and 48. And since this is a side, I'm going to round to 2 decimals. So I get 6.928. I'm rounding at the 2. The 8 is big enough to make the 2 go up. So this is 6.93. So for this section, please use the last page of your notes packet, which tells you all of the methods for solving both right triangles and non-right triangles, and hopefully you can be able to tell when you should use each method. In G, it says solve each triangle, round missing sides to 2 decimals and missing angles to the nearest degree. So when we solve a triangle, we have to find everything that's missing. So notice for 26, I'm missing angle A, I am missing side AC, and I'm missing side CB. I'm going to start by finding angle A because I know that all of the angles in a triangle add up to 180, and since I know that one of the angles is 90 and the other is 53, I can just subtract from 180 to figure out what has to be left. So 180 minus 90 minus 53 gives me 37 degrees for angle A. And now I need to solve for the sides AC and CB. I'm going to start by finding side AC. So I'm going to label that X. And in order to do this, I'm going to use SOHCAHTOA because I don't have enough information for the Pythagorean theorem. When you're using SOHCAHTOA, all you need is one reference angle. If you look at 26, I have 2 to choose from. I could use the 37 degrees or the 53 degrees. It doesn't matter which one you choose. I typically tend to choose the one that they gave me. So I'm going to have 53 be my reference angle, and I'm going to label my sides. I have my opposite side, my adjacent side, and my hypotenuse side. Looking at my labels, it looks like I'm going to want to use the opposite and the hypotenuse. According to SOHCAHTOA, O and H is sine. So the sine of 53, since that was my reference angle, is equal to x over 5. I'm going to put a 1 under my sine and cross multiply. 1 times x is x. And then in my calculator, I'm plugging in 5 times the sine of 53. And I'm going to round to 2 decimal places. So I get x equals 3.993. Rounding at the second decimal, the 3 is not big enough to make the 9 go up, so this is just going to stay 3.99. And that was for AC. Lastly, I need to find CB, so I'm going to label that Y. And I'm going to do SOHCAHTOA again, and I'm going to use the 53 degrees again because all of my sides are already labeled from that point of view. Instead of using the opposite in the hypotenuse though, since I'm trying to find y, I'm going to use the adjacent in the hypotenuse, which will be cosine. So cosine of 53 is equal to y over 5, and I cross multiply. 1 times y is y, and in my calculator I'm going to plug in 5 times the cosine of 53, and I get 3.009. Rounding at the second decimal, the 9 is big enough to make the 0 go up, so this will be 3.01. So when you solve a triangle, you need to make sure that you find all missing sides and angles. It does not matter the order that you find each piece, and sometimes the more that you find, the more options it opens up for you. Let's try to solve a non-right triangle now. So looking at 28, I have a non-right triangle. I need to find the measure of angle B, the measure of angle C, and BC. If you notice, it looks like I have SAS, and if I put an X right here for BC, I'm set up to use the law of cosines. So let's label our little letters. Across from big A, I have little a. Across from B, I have little b. And across from C, I have little c. Since I'm trying to find little a, that's the law of cosines I'm going to start with. So a squared equals b squared plus c squared minus 2bc cosine of a. I'm going to plug in my information. So I have x squared equals little b is 27, little c is 21. Once again, little b is 27, little c is 21. And I know that angle A is 102 degrees. In order to get x by itself, to get rid of the square, I need to square root both sides. And then you get to plug all of this into your calculator. So to get the square root, we do second x squared. I'm going to type in 27 squared plus 21 squared minus 2, parentheses 27, close your parentheses. Another parentheses, 21, close your parentheses, cosine of 102. I get 37.493, and I'm rounding to the second decimal. The 3 is not big enough to make the 9 go up, so this stays 37.49. Notice how now that I have that side, I have a complete pair. So if I want to find the measure of angle B now, I now have a complete pair to use the law of science. So I can say the sine of 102 over that 37.49 is equal to the sine of angle B over 27. I'm going to cross multiply. So I get sine of 102 times 27 equals 37.49 times the sine of b. To get b by itself, I'm going to divide by the 37.49 to both sides. And notice how the b is being blocked by the sine, which means to get rid of the sine, I need to use the inverse sign. So second sine of the sine of 102, so make sure that you have two sines back to back. One is the inverse and one is the regular, times 27 divided by 37.49. And since this is an angle, I'm rounding to the nearest whole number, so I get 44.7, rounding at that 4 right before the decimal, and the 7 makes the 4 go up to 45 degrees. And to finish this up, even though this is a non-right triangle, all of the angles still add up to 180 degrees. So 180 minus 102 minus 45 will give me that angle C is 33 degrees. So notice how for this triangle, I never used Pythagorean theorem, I never used SOHCAHTOA, because this is a non-right triangle. You can only use the law of sines and the law of cosines. Let's finish up this video with a word problem. So from point P on the ground, the angle of elevation of an airplane is 23 degrees. The altitude of the plane is 1,200 meters, so it's 1,200 meters above the ground. It says, what is the distance from point P to the airplane to the nearest tenth of a meter? So I'm trying to find the hypotenuse. I want to know what is the distance from point P to the airplane. And I'm rounding to the nearest tenth, so that's 1 decimal. I'm going to start by labeling my sides. So I have opposite, adjacent, and hypotenuse. It looks like I have the opposite and the hypotenuse, which will be sine. So the sine of 23 is equal to O over H. So 1,200 over X, and I cross multiply. 1 times 1,200 is 1,200, which is equal to X times the sine of 23. And to get X by itself, I need to divide by the sine of 23. So 1,200 divided by the sine of 23 gives me 3,071.16. I'm rounding to the first decimal, and the 6 is big enough to make that 1 go up. So my final answer is 3,071.2 meters. And why don't we do the last word problem too? Brenda wants to use a clinometer to measure the height of Miss Spellberg's classroom. So if you remember, this is the activity where we went outside to measure the buildings. So I have Brenda, and she has her clinometer. So it's the protractor with the little straw. While holding the clinometer 4 feet above the ground and 10 feet away from the classroom, so the angle from her eyes to the top of the classroom is 43 degrees, and she's 10 feet away from the classroom. What is the height of the classroom? So I'm going to label the sides from the 43 degrees. This is my opposite, this is my adjacent, this is my hypotenuse. It looks like I have opposite and adjacent, so that's going to be tangent. Tangent of 43 is equal to O over A, so X over 10. And I cross multiply. 1 times X is X. And then I have 10 times the tangent of 43. I'm going to plug that into my calculator. And rounding to 2 decimal places, I get 9.325. So looking at the second decimal, the 5 makes the 2 go up to a 3. But remember, when we did the activity outside, this wasn't the final answer because we only found this section of the height. In order to get that last missing piece, I have to add the eye height. I have to add the height that the clinometer was above the ground, which was the 4. So plus 4 tells me that the height of Miss Spellberg's classroom is 13.33 feet. So if you get a clinometer word problem on your test, after you do your SOHCAHTOA, please make sure that you add the eye height or the height of the clinometer at the very end. And that was your Chapter 6 study guide. Please let me know if you have any questions while studying, and make sure that you practice your rounding.